Now that you've learned the basic properties of exponential and logarithmic functions, meet its evil twin brother, inverse exponential and logarithmic functions. Now, it is kinda a rite of passage to learn the inverse of one thing. Like we discussed last time, domain and range can be inverse, or even music notes can be inverse too. So in this video, you will learn the art of inversion in this field, perfecting the yin and yang of solving logarithmic and exponential functions. So let's go.
To give you all some ideas about our topic, here are some definitions. Inverse function. An inverse function is a function that has the purpose to reverse the inputs and outputs. This is where it returns the initial value for which a function has given the output. Logarithmic function. Logarithmic functions are the inverses of exponential functions. Exponential functions. Exponential functions are functions wherein their exponents are variable and the base is constant. So this is a sample of how we convert the logarithmic function to its exponential form. As you can see, the constant from the logarithmic function will be the base of our exponential form. The equivalent value of the logarithmic function will be the exponent of our base in the exponential form. The expression besides the logarithmic will now be the equivalent value of our exponential form. Now we have two samples here. The top one is the normal logarithmic function, and the bottom one is the inverse version of that. We'll talk about that more later. But now that you get a little gist of what is this all about, I'm gonna show you some more examples that will help you understand this better. First, we got logarithmic of y with a base of 3 equals to x, and its exponential form is 3 raised to x equals 5. So like what we talked about earlier, all you need to do is jumble it basically. So you put 3 as our base and x as our exponent, which is the equivalent value from the logarithmic expression earlier, and the expression y will be the equivalent value, 3 raised to x equals 5. Next one is logarithm of 16 with a base of 2 equals to 4. Now, if you express it to exponential form, it will be equivalent to 2 raised to 4 equals to 16. The same process as earlier. Easy, right? Logarithm of y is equals to x, and its exponential form is 10 raised to x equals y. Now you all might be asking, where the hell did 10 come from? Now there's really some simple explanation to that. Since we don't have any indications of bases in the logarithmic function, it is called common logarithmic. Common logarithmic doesn't have any bases. And since it doesn't have any bases, the automatic value will be 10. So yeah, 10 raised to x equals y. Next, we got logarithm of y with the base of x plus 2 is equals to 2. Now don't be intimidated just because it have a binomial base. It's actually very simple. All you have to do is just like before. Put the base, turn the equivalent value to exponent, put it beside the base, and then take the expression from the logarithmic function, turn it to equivalent value in the exponential form, and there you go. You got the exponential form. X plus 2 raised to 2 is equals to y. Next, we got natural logarithm of y equals to x. It can also be written as logarithm of x with the base of e equals to x. And its exponential form is e raised to x is equals to y. These right here are the steps in finding the inverse of the logarithmic and exponential functions. First, we replace f of x with y, then interchange x and y, solve for the y, then replace y with the f inverse of x. I'm now gonna present to you Mr. Liros to discuss this topic to you all further.
So, let's put into use all that we've learned from Sir Dion. So we have your f of x equals log base 3 of x minus 5. So before that, I want to tell you that we have put all the steps in the top left section. So you can avoid forgetting the steps, and maybe you can follow us while we're doing the problem. So with all that, let's start solving, inversing the function. So firstly, according to the first step, we need to replace f of x with y. So that means we just only need to replace f of x in this equation with y. And that will become y equals log base 3 of x minus 5. That's simple, that easy. You solve the first step. Second step, we just need to interchange x and y. And that only means that we need to swap the places of x and y in this equation. So now it will become x equals log base 3 of y plus 5. And that's it. Second step is finished. And next is the third step, solve for y. Well, in that part, I think it's going to be a little bit hard, but don't worry. If you listen to your grade 10 teacher in math, or you watch our other videos about the discussion in basic operations, trust me, you'll find it easy. It's easy as pie, trust me. So in here, we're just going to transpose negative 5 in the left side. So why that, you ask? Why did we transpose the negative 5 on the left side? Actually, we need this logarithmic function to solve this inversion, because that's the only way we can transform into exponential function form. So if you see here in this equation on how to transform into exponential function, we need the logarithmic function first. So if you observe, we passed all the requirements into making logarithmic functions. So here we have our logarithmic function. The x plus 5 equals log base 3 of y. So what's left now is just turning it into exponential function form. So if we follow the steps here, if we understood all the steps here and the parts of it, we'll come up with the answer 3 raised to x plus 5 equals y. And that's it. You finish the solve for y. That easy. So what's next? What's only left is the fourth step, which is to replace y with f inverse of x, or the f of x with the negative exponent. So let's just turn this around to make it a little bit easier to observe. And then we'll just do that, the inversion of y into f inverse of x. Let's write it here, and we're done. That's it. We've inversed the function. So maybe let's try the next question, you may ask. So we have here f of x equals to ln of x minus 5 plus 3. So we'll start inversing it. First, we're just going to replace f of x with y, and that's really easy. Next, we're going to interchange x and y. So we're just going to swap their places with each other, and we will have x is equals to log base e of y minus 5 plus 3. So you'll notice there that there is a log. We change the element to that to make the inversing easier, and we place e because that is the base of a natural logarithm. So after that, we're just going to solve for y. To do that, we're going to transpose first the positive 3 to the other side, and now we will have x minus 3 is equals to log base e of y minus 5. So we're going to look again to this equation and how to transform to exponential functions. And if we follow it, we're going to have e raised to x minus 3 is equals to y minus 5. So last thing to do is we're going to transpose negative 5 to the other side. So it's going to be e raised to x minus 3 plus 5 equals to y. And now we solve for y. The only thing to do is to replace y with f inverse of x. So if we replace that, we're going to have f inverse of x is equals to e raised to x minus 3 plus 5. And there you have it. You solve another, or inverse another, logarithmic functions. So, thank you for watching. Yeah, if you want more comprehensive videos, just click some of the videos in your channel, maybe subscribe, or like the video. That's it. And be a Gen Matalino. Thank you.